Big Bang Theory is the most widely believed theory of how our universe came into existence. It suggests that a sudden expansion gave birth to our universe, and it was created in a specific instant 13.8 billion years ago. The evolution of how we came to be has been broken down from the first fraction of seconds when the first photons filled space. Dwarf galaxies, planets, and black holes are known to exist by the time our universe was 4.5 billion years old. Fast forward to the early 1600s, when Galileo's telescope brought expansive new understanding of our galaxy. It was learned that the Milky Way wasn't just a cloud, but a compilation of stars, that Saturn had rings, and that Jupiter had moons. Another telescope brought more knowledge in 1990 when the Hubble telescope was launched. It has allowed astronomers to view black holes, planets, stars, and other astronomical phenomena. It's also led to new beliefs about the rate of expansion of the universe. Our solar system consists of the Sun, 8 planets, over 170 moons, dwarf planets, asteroids, comets, and meteoroids. NASA recently released images from the Hubble telescope revealing multicolored stars. This cluster is believed to have stars that were born millions of years apart. This is another example of how technology can change the way we see things. Now that we know how we got here, let's move on to the concepts that describe the workings of our universe. These often are explained in laws. Newton came up with 3 laws that explain a law. His first law is sometimes referred to as the law of inertia. Inertia is the natural tendency of an object to remain in a state of rest or in uniform motion. This can be displayed with a magnet. If you place a little magnet above another, it will appear to float and will remain at rest unless you give it a tap. It will then begin to spin. It won't stop either unless we step in and stop it. This explains why the Earth spins. It was formed out of dust that was spinning. It keeps spinning because mass keeps its state of motion.
So let's fast forward millions of years, as the spinning of gas and dust formed not only our solar system and planets, but more specifically the Earth. It's mind-blowing to think of what a vast planet we live on. However, the study of geology has helped us gain a better understanding of the Earth's complexity and its composition. Let's begin from the inside out. Initially, the core formed and consists of a solid inner core, made from heavy materials like iron and nickel, and a liquid outer core. Altogether, the core is about 800 miles thick. Next is the mantle, which is the rocky composition and measures about 1,400 miles. Last is the crust, which is the outermost layer of Earth. It's approximately 3 to 24 miles thick. For a better visualization of just how deep or thick the Earth is, imagine the distance between Seattle and New York City. Because of its incredible depth, as well as the progressive rise in temperature, no one has succeeded in even reaching the bottom of the Earth's crust. With this in mind, you might wonder how we even know any information about the mantle and inner core. This information has actually been obtained by studying waves and their movement across and through the Earth. The world as we know it with the 7 continents did not originally exist. Rather, it was initially one large landmass called Pangaea, which is a Greek term meaning the entire Earth. The scientist Alfred Wegener is actually credited with this discovery. He introduced the idea that the landmasses drifted apart due to the shifting movement of plate tectonics. This is known as continental drift. In support of his theory, he identified that the coastlines of the continents actually matched each other and could potentially fit together like puzzle pieces. Further support of his theory has been found in fossils. These fossils supported the presence of identical species of both plants and animals that were found on different continents that are now miles apart and also separated by oceans. So now we have a basic understanding of how the world was created and how things work on a larger scale. But it's chemistry that really helps us understand the inner workings. The discovery of a minute particle called the atom revolutionized the world of science. An atom is the smallest unit of ordinary matter and is the basic unit that composes every solid, liquid, and gas. It contains a nucleus of protons and neutrons orbited by electrons. After the discovery of the atom, scientists went on to discover elements and began trying to arrange them based on their recurring properties. They also arranged them based on the atomic numbers, which is derived from the total number of protons in the atomic nucleus. It was a Russian scientist, Dmitry Mendeleev, who is credited with creating the first version of our modern periodic table. at which time there were approximately 63 elements identified. With the discovery of new elements, today there are 118 elements listed on the periodic table. You might ask if the periodic table is still relevant, or is it just a piece of information placed in a book and forgotten? The answer is no. Currently today, researchers are actively striving to develop a vaccine to combat COVID-19. An article in the New Yorker describes the challenges of mass production of vials. The problem is that they rub together creating a dust, which then contaminates the medicine. Through research done at Corning Technologies in 2011 to 2017, scientists have discovered a new type of glass called Valor glass, which has eliminated this problem. The timing for this new technology couldn't be better, as laboratories try to prepare and distribute millions of vials of the COVID-19 vaccine. When asked to discuss the process used to discover Valor glass, one of the researchers, Robert Schad, remarked that they used the periodic table as their toolbox, as they added and removed elements to find the ideal composition. In this particular discovery, they added the element alumina and removed boron, which made the glass stronger and less likely to degrade and contaminate medicine within the vials. Lastly, David Morse, who is the Chief Technology Officer at Corning, states, and I quote, "Mendelov's work is forever relevant, and we have more than enough building blocks to keep us inspired and innovating for eternity."